Carbon. For all your organic chemistry. Shiny rocks and jewellery. And for when you want to photosynthesize. But what is carbon and why is it viewed as an element that's essential for life? Let's take a look. Carbon is the sixth element in the periodic table, and as such it has 2 electrons in its inner shell and 4 on its valence shell. This means it easily forms 4 single bonds in things like methane, 2 double bonds in things like carbon dioxide, even triple bonds in things like nitrile groups. As it can form tetrahedral shapes, it can form 3D molecules, unlike things that form 3 bonds or 2 bonds, which tend to be planar. Carbon-to-carbon bonds are also quite strong, but not too strong that they can't be overcome. Carbon also forms many allotropes, that is, structures made from just one element. And obviously you have things like diamond and graphite. Now personally, I've always wondered how a structure like graphite ends, because in theory, it's infinite, but the answer is, like diamond, it can be ended with a hydrogen, which is often why graphite is duller on the outside than if you freshly cut it, or you can chuck on any functional group from organic chemistry. Now graphene is entirely different, and it's quite complex, so bear with me. If the carbons aren't perpendicular to each other, it's called a zigzag edge. And if they are, it's called an armchair edge, because it looks like an armchair. Zigzag edges are magnetic and so are really useful in nanoelectronics and spintronics, whereas armchair edges are semiconducting. Next on the list of allotropes is carbon nanotubes. This is exactly what the name says it is, a small tube made of carbon, and it's closely related to the fullerene. Both have massive potential in biochemistry and medicine, and have been considered to be used for cancer treatment and things like that, as well as drug delivery into the body, because carbon is non-toxic. On the topic of carbon-based medicine comes this beautiful thing, charcoal, which is basically amorphous carbon with some impurities in it, but it's supposed to be purely carbon. And charcoal's really interesting because obviously it's used as a fuel, but if you activate it, you get activated charcoal, and this is super absorbent, and they use it in cases where people overdose or swallow something they maybe shouldn't have. Although all the cosmetic products with activated charcoal in, most government health agencies seem to think it's a load of nonsense. Finally, you have Lonzolite. Lonzolite? Who knows? Whatever it's called, it's diamond, but unlike the diamond we discussed earlier, it's arranged in a hexagon shape rather than a cube. In essence, it's the same as regular diamond. If anything, it's just slightly harder because of the hexagon shape. Finally, just because it was a question I saw that I found quite interesting, is why is silicon not as good as carbon? And the answer is because it's a larger atom, it doesn't form pi bonds as well, so struggles to make double bonds or triple bonds. And that's it for this week's video. Thanks for watching, I hope you enjoyed. Remember to like and subscribe, and feel free to join me next week when I'll be talking about fireworks. Thanks, bye.